In this video, we're going to talk about, we're going to do an example of integrals that involve trigonometric functions. So, for example, let's say we're given a function f at x is equal to the secant squared of 3x, and then we're asked to find the integral of f at x dx. So here we're being asked for an indefinite integral because there is no interval on the integral sign here. So we're being asked to find the integral of the secant squared function. So how do we find that? Well, as you know, the integral of a function is the opposite of a derivative. And if you look at a secant squared function here, you may notice that a secant squared of something is the derivative of a tan function. Okay, so the derivative of a tan function is a secant squared function. Therefore, the integral of a secant squared function must be a tan function. So in our previous method, we used in previous videos, we used a method of substituting in this bracket for a placeholder. So that's what we're going to do in this video. And if you haven't seen the previous videos, I'll link them here. But I'll show you how we use this method of placeholders to help us evaluate this integral. So let's say, okay, we'll call our placeholder a box here like this. Okay, we can call it T, we can call it U, we can call it whatever. In this case, we just call it some empty space. And this box is going to represent what's in this integral, or in that bracket there, which is 3x. What we're going to do is, from this point on, we're going to take the derivative of that box there. So d box by dx is equal to 3. Now we've defined our placeholders, we can go ahead and actually start working on this integral here. So what this question is asking us is, we want to find the integral of the secant squared of 3x, right, dx. Right. Now, of course, we can just convert this to a tan function. We can't just say, okay, this is equal to tan 3x, because the reason why is it doesn't account for what is in this, what's in this box here. It doesn't account for this 3x. So a way to think of the integral of a secant function is this. Okay, the integral of a secant squared of something times the derivative of that something with respect to x dx is going to equal tan of whatever is in that box plus c. So in order for us to go from secant squared to tan, we have to put this integral in a way that it adheres to this form right here. Okay, so secant squared d box by dx times dx. So that's what we're going to do here. So we're going to go and do this. So this would equal the integral of secant squared of our placeholder dx. Okay, but as you can see here, now that there's a placeholder in here, we want to be differentiating with respect to the placeholder and not necessarily x. So what we'll do is we'll just multiply it by our d box by dx, which is 3. Okay, so we're going to have secant squared of our placeholder times the derivative of the placeholder with respect to x dx. And you can sort of visualize it as these dx's canceling out, and now you are integrating with respect to this placeholder. So when we plug our numbers in, we get this. We get the integral of secant squared 3x times our d box by dx, our derivative of our placeholder, which is just 3, so times 3 dx. Okay, but here we have a slight problem here. Even though this is in the right form for integration, so this is in this form here, this entire expression is different than this, right? We want those two expressions to be the same, right? The 3 makes it different, right? Because we're multiplying by 3. So if we want to make this the same as this, you have to cancel out the 3. And a clever way of doing that is just putting a 1 over 3 here. So the 3's cancel out. And as you can see, this expression, though in a slightly different form, is the exact same as this expression, but also the integrand here is in the correct form for integration there. So now what we can do is we can actually go ahead and convert this to this. So what we get in the end is 1 over 3 times that times tan of our placeholder, which is 3x plus c. And that would be our answer.